Okay, so now it's the turn of Younn Blizard Cabañas. Younn holds a bachelor degree in biology from the University of La Laguna and completed a master's degree in marine biology, diversity and conservation. During this time, he participated in various oceanographic campaigns with the Spanish Institute of Oceanography and in several research projects. He is currently specializing in benthic ecology, and his talk will be Faunistic studies around the new submarine lava substrates of the Tajogaite volcano and the Tagoro volcano complex.
Thank you so much. Perfect. Vale. Well, thank you everyone for coming today. Today I'm going to talk about the faunistic studies around the new lava substrates from the Tajogaite and the Tagoro volcano complex. Well, first of all, I'm going to give a brief context of the situation. First, the Tagoro volcano entered in eruption in 2011. It created a volcano complex of hundreds of meters, and it stopped at more or less 80 meters below sea level, 88 actually. And nowadays, there still are hydrothermal vents that creates different environment situations for the benthic fauna. In the case of the Tajogaite volcano, this is another type of volcano because it's an aerial volcano that the lava flows enter in the sea and create some submarine lava flows from the lava delta. We have seen that the submarine lava flows entered until almost 200 meters below sea level, but there were still signs of high haloclastites and ash at 400 meters below sea level and 1.2 kilometers offshore from the entrance of the lava. What we did first, in the Vulcana 3 oceanographic campaign in October 2021 during the eruption, and with the ROV Liropus, they did 20 dives in total, 10 concentrated in the Tagoro volcano, and another 10 dives in front of the area of the lava delta of the Tajogaite volcano, while the volcano was active. And also, I want to say that also there is a control area that it was possible to do a dive in February of 2022. So we use it as a controlled area to contrast the difference between these areas and how the volcano affected directly on the benthic fauna. What we did first, we filtered all the dives to search for the most interesting records, and we found 7 videos from the Tajogaite volcano, 6 from the impact area and 1 from the control, and 6 videos from the Tagoro volcano. And through the VR software, which is viewing image for ecosystem research, we collect different data. First, the species taxa, the abundance of the taxa, and the geographical position and time and depth of the individuals that we have seen throughout the whole videos. And also we collected the type of substrates where these species were found. As a result, in the case of the Tagoro volcano, we found 7 phyla in total, with 9,288 individuals, and 22 taxa were observed. But also, we want to highlight in this graph with the abundance of the species, but transformed to the log 10, that Chordata was the most observed group, followed by Nidaria and Annelida. In this case, the species most observed was the Antias, this marine goldfish, I think is the name. And as you can see, it is always found in high densities near rocky substrates. And then the second group most observed was the Nidarians, and in this case, this is a black coral, the Antipates furcata, which presents a short length. It's a short length branched coral. That was also found in the summit of the volcano. And on the third position, the Annelids, we found the fireworm, Hermodice carunculata, that was presented in all the areas that we have seen on the videos, which is very interesting afterwards. Here you can see a graph with all the 3 different substrates that we categorize on the videos in the Tagoro volcano. First one is the Younn Blizard. In this case is substrate with a small boulders that by gravitational movement they have been assembled in some areas where there is a high steep, and as you can see there is not too many biodiversity found there. But then, for example, in contrast, rocky substrates always present higher the biodiversity, which is what we expect. Then the rosette represents basically the places where we found mats of Thiolava veneris. And here, for example, we have seen more biodiversity than in Younn Blizard, but especially when we found annelids that were present around the hydrothermal vents. And here you can see a photo of how we said what is rosette. You can see these places where mats of Thiolava veneris are present, and there's not too much sessile life there. Then the Younn Blizard, here you can find the small boulders that are assembled, and finally the rocky substrate where the biodiversity is clearly totally abundant compared to the other substrates. About the species distribution, we've decided to map all the presence of these species to see if there was any pattern, especially on the, for example, between the faces of the volcano. And we found, for example, some interesting things in the case of the cnidarians, the structuring species. For example, in the orange dots, Antipathes furcata was found especially on the top area of the volcano, while Stichopathes gracilis, the whip black coral, was mostly present a few meters deeper, around 40 meters deeper, but also with some representation of both species in both areas, but with less abundance. But on the other case, Dermodice caranculata, the fireworm, was presented, although it was presented in the rocky substrates, it was always presented on the hydrothermal vents, which is only interesting because this species is, by its feeding habits, it is scavenger, also a predator, so it is interesting to see this kind of colonizers arriving in the hydrothermal vents. Changing the situation, the place, we go to the Tajogaite submarine lava flows. In this case, we found 12 phyla with 159 taxa and more than 26,000 individuals. Especially the first group, or more important, well, sorry, for the impact area we found 16,915 individuals, and from the control area 9,313 individuals, just in one dive compared to 6 dives. And what we can highlight here is that Cnidaria was the most important group that we found, especially this species, the Stichopathes gracilis. I talked a little bit before, because normally it presents high densities, especially in the cercalitera and sometimes in the bathyal range. But also we found the second one, the Anomocora fecunda. These scleractinians present a short length colony that it's highly branched in a massive and whitish form. Normally it's presented in forming some sort of gardens of corals and cohabiting with, for example, other corals such as Bebrice mollis. Then we found in the circalittoral species such as the famous black coral here in the Canary Islands, Antipatella wollastonii, which normally you can find it forming live belts, belts of reef belts around the islands, and followed, for example, by Unicella verrucosa, or another whip coral, Biminella flagellum, that normally belongs to the bathyal range. In the second place, the porifera, most of the sponges are truly difficult to identify through video sources, but at least in this case, for example, Axinella sp genus was the most observed. Probably here is Axinella damicornis. This one is normally observed in the circalittoral. followed, for example, by Litistida indeterminate. In this case, you can see many massive white sponges that are partially or totally covered by ashfall, and that at the moment they are probably dead because they were blocking the filters, the pores where they filter the water. And the third group was the Brachiopoda. Here we found just one species, which is Meherlia truncata, and you can see in the rock that maybe there's nothing there, but actually there are many organisms there. These small rounded forms are actually this brachiopod. And it is known that once they appear in high densities, covering, for example, one rock with hundreds of individuals. We check also the density of individuals per square meter in all the dives, and we found that in the control, the density was almost 12 individuals per square meter, but in contrast, for example, the 13th dive was presented no signs of life. Why is this? Because these dives, for example, were done over the new lava substrate, where we don't expect to have any type of sessile life, at least. And the communities that we found in the Tajogaite submarine lava flows, first of all, in the upper bathyal, from 400 to 100 meters below sea levels, we found that communities formed by Anomocora fecunda, Stichopathes gracilis, as I said before, but also we found in sandy substrates this hydrozone, pretty interesting, which is called Lithocarpia myriophyllum, that presents a high biodiversity community assembled to it. We didn't find, as you can see in the graph, control versus impact area, we didn't find any representation of these species in the control, but because we didn't find any sandy substrate. On the other hand, for the lower circulateral, from 200 to 100 meters below sea level, the community changed a lot. Anomocora fecunda reduced its presence, but in contrast, Stichopathes gracili is the main nidarian, and there are other nidarians less abundant but interesting, such as Elisella parapleuxauroides, Antipatella wollastonii, or Antipathes faucata, another black coral. And finally, the upper circalittoral community, from 100 to 50 meters below sea levels, the community doesn't change too much because actually it's the same group, it's the circalittoral. But we found, for example, that Axinella cp or Demospongia indeterminate 9, which is yellow, massive, were most abundant, as well as some. We started to see some macroalgae in the area. And finally, what happened to the new lava substrate? Well, we didn't find any kind of sessile life, but what was interesting is that fishes were still there. At the moment of the eruption, fishes were there. So that presents that the first group to arrive to the new lava substrate, even during the eruption process, are fishes. But also, we found something interesting, and it's that among the different lava substrate, it was possible to look and to find small hotspots biodiversity of corals, especially the of Antipatella wollastonii, with Axinella damicornis and the Demnidae. So in the end, this would be interesting to analyze for future studies in the case that these small patches of life can help in the recolonization process of the new lava substrates of the Tajogaite volcano. And this would be everything. Thanks for your attention.